Imagine a massive explosion on the sun, millions of times stronger than any atomic bomb ever created. Now imagine that explosion flinging billions of tons of superheated plasma into space at millions of miles per hour. That, my friends, is a solar storm. These aren't just visually stunning cosmic events, they're forces of nature that can have a real impact on our planet. These storms are a reminder that the sun, our life-giving star, also possesses a fierce and unpredictable side. Like a sleeping dragon, it can awaken with a fury that sends shockwaves across the solar system. Thankfully, scientists are working hard to understand these storms, to predict their arrival, and to mitigate their impact on our increasingly tech-dependent world. So buckle up! We're about to embark on a thrilling journey to explore the science behind these incredible solar events. We'll unravel the mysteries of solar flares and coronal mass ejections, learn how these storms travel through space, and discover their awe-inspiring and sometimes disruptive effects on Earth. This isn't just about abstract science, it's about understanding a force of nature that can affect our daily lives. So get ready for a cosmic adventure as we delve into the heart of solar storms and their impact on our world. Solar flares are like the sun's explosive temper tantrums. They're sudden, intense bursts of energy that release a tremendous amount of radiation, including X-rays and gamma rays, into space. These flares originate from sunspots, which are cooler, darker regions on the sun's surface caused by intense magnetic activity. Think of these sunspots as giant tangled knots in the sun's magnetic field lines. When these knots snap and reconnect, they release a massive amount of energy in the form of a solar flare. This energy can be equivalent to millions of hydrogen bombs exploding simultaneously, making them one of the most powerful events in our solar system. The light from a solar flare reaches Earth in just 8 minutes, traveling at the speed of light. While most of this radiation is harmlessly absorbed by our atmosphere, some of it can disrupt radio communications and GPS signals. So the next time your GPS acts up, you might have a solar flare to blame. If solar flares are the sun's temper tantrums, then coronal mass ejections, or CMEs, are its sneezes. They're massive eruptions of plasma and magnetic field from the sun's corona, the outermost layer of its atmosphere. CMEs can hurl billions of tons of solar material into space at speeds of millions of miles per hour. Imagine a giant bubble of superheated gas, laced with magnetic field lines being ejected from the sun. That's a CME. These events are often associated with solar flares, but they can also occur independently. Unlike solar flares, which emit mostly radiation, CMEs are all about matter, a giant cloud of solar material hurtling through space. These solar sneezes can travel much slower than the light from a solar flare, taking 1 to 3 days to reach Earth. But when they do, they can trigger the most intense geomagnetic storms, disrupting our planet's magnetic field and causing widespread auroras. Once a CME erupts from the sun, it embarks on a journey through space, riding the solar wind. The solar wind is a constant stream of charged particles flowing from the sun in all directions. This wind carries the CME's cloud of plasma towards Earth, like a surfer riding a wave. Think of the solar wind as a cosmic highway, and the CME as a giant truck barreling down that highway. As the CME travels, it interacts with the solar wind, sometimes being accelerated or deflected by its flow. This makes predicting the CME's exact arrival time and impact on Earth a complex challenge for scientists. The Earth's magnetic field acts as a shield, deflecting most of the solar wind. But when a CME hits, it's like a giant hammer blow to our magnetic shield. This impact can trigger geomagnetic storms, disrupting our planet's magnetic field and causing a cascade of effects on Earth. Section 5. Auroras, dancing lights from the sky. One of the most spectacular and beautiful effects of solar storms is the Aurora borealis, or northern lights, and its southern counterpart, the Aurora australis. These dazzling light shows occur when charged particles from the sun, carried by the solar wind or a CME, interact with Earth's magnetic field. Imagine a cosmic ballet of light with shimmering curtains of green, red, and blue dancing across the night sky. That's the aurora. The colors are produced when the charged particles excite atoms in the Earth's atmosphere, causing them to emit light. While auroras are a breathtaking sight, they're also a visible reminder of the sun's power and its influence on our planet. These dancing lights are a testament to the dynamic interplay between the sun and Earth, a cosmic dance that has been going on for billions of years. Section 6. Technological impacts. When the sun disrupts our tech. While auroras are visually stunning, solar storms can also have a disruptive side. Geomagnetic storms triggered by CMEs can induce electric currents in power grids, disrupting electricity supply and potentially damaging transformers. Imagine a blackout across a whole city or region, all caused by a solar storm. Our increasingly technology-dependent world is particularly vulnerable to these solar outbursts. Satellites can be damaged or even disabled by the intense radiation and charged particles from solar storms. GPS signals can be disrupted, affecting navigation systems used in aviation, shipping, and even your smartphone. It's like a cosmic EMP blast that can knock out our technological infrastructure. Understanding and predicting these space weather events is crucial for protecting our technological systems and ensuring the smooth functioning of modern society. Section 7. The importance of solar storm research, protecting our future. Studying solar storms isn't just about understanding a fascinating cosmic phenomenon, it's about protecting our planet and our way of life. As we rely more and more on technology, we become more vulnerable to the disruptions caused by space weather. Scientists are constantly monitoring the sun, using sophisticated instruments to track solar flares and CMEs. They're developing predictive models to forecast the arrival of these storms and their potential impact on Earth. Think of it as a cosmic weather forecast, but instead of rain or snow, we're tracking solar storms. By understanding the science behind these events, we can develop strategies to mitigate their impact. This includes designing more resilient power grids, protecting satellites from radiation damage, and developing early warning systems to alert us of impending solar storms. Section 8. Conclusion: Respecting the sun's power. Solar storms are a powerful reminder that we live in a dynamic and interconnected solar system. The sun, our life-giving star, is also a force to be reckoned with, capable of unleashing tremendous energy that can affect our planet and our technology. As we continue to explore and understand these cosmic events, we gain a deeper appreciation for the sun's power and its influence on our world. But more importantly, this knowledge empowers us to protect ourselves from the sun's fury, ensuring a safe and sustainable future for humanity in the age of space exploration. So, the next time you see a beautiful aurora illuminating the night sky, remember the awe-inspiring power of the sun and the importance of understanding its sometimes unpredictable behavior. Let it be a reminder that we are part of a vast and dynamic cosmos, and that exploring and respecting the forces of nature is essential for our continued survival and prosperity.